So anyways, today I want to talk about the research that I've done over the last 20 some years on birds in the urban environment. And I want to really emphasize that, and I say here, essential contributions by, these are all of my former students who worked on this project in one form or another. And quite honestly, I collected very little of the data that I'm going to talk about today because I got my students to do all the work for me. That's the trick of it. Get them to do it. Give them ideas, support them, but let them go out and do the research. And we were supported by a number of institutions that I'll show right here. So in any case, how did I get started? Oh, that's right. How did I get started on working? Sorry. I just wanted to point out, I'm terrible at coming up with titles. And so when Stan asked me if I'd be interested in giving this talk, I said, sure. And then I had to come up with a title real fast. And so I sat down and I wrote this, The Modern Bird World. And then suddenly I'm thinking, Stevie Wonder, Living for the City. Perfect. Okay. So I give my shout out here to Stevie Wonder. Great music. And the title fit my title very, very well. So over the years, I've had the opportunity to work in a number of really gorgeous places. Up there on the left corner, that's where I used to live in New York State, where Stan and I first met each other. And I've also worked in South Dakota along the Missouri River, the Bahamas. My wife right there, she and I took students to the Bahamas for half a dozen years to teach classes and do some research. Wetlands of Louisiana, Wichita Mountain Wildlife Refuge in Oklahoma, and then most recently Malheur Wildlife Refuge in southeastern Oregon. I've had the opportunity to work in all these phenomenal places. And that's part of the reason why I became a biologist, a field biologist, was to actually go out and experience the world and see all these places. And it's worked. So then you might ask, well, why in the world would anybody who's had the opportunity to do that decide to work there? I hate cities. I friggin' hate them. I really do. If I could move out of Portland, I would. And Portland's a nice place, but I just don't like living in the cities. So how is it that I actually came to being in this place and conducting this research? And by the way, if you have any questions, just shout them out, okay? I'd rather just kind of take them as they come, as you make sure we understand it. The reason why I'm here has to go back to this place, Hartwick College, where Stan worked, and he talked to you a little bit about this already. It's the four-year liberal arts college with a student body of about 1,450 people. Our biology department had 7 faculty members in it. We graduated about 20 to 25 students per year. But as Stan said, we were able to do research there and did some really high-powered stuff. I don't know if you know, he published a paper in Science with his undergraduate students. That's no small feat. Okay, so, but we were supported by the college there. And the times that I was there with Stan, he already mentioned that he came in a year after I did. Again, it was a great relationship because he and I did things that nobody else did. Okay, and we were mutually supportive and all that. And moreover, there was just this certain resemblance to a certain fellow who's kind of famous. Okay. And he had what? He had better teeth. Okay. Yeah. But Stan was he still is one of the most creative thinkers I've ever been around. I mean, he's just like, brain candy. It's just fun being around. We had so many good discussions about stuff. And evolutionary biology is one thing that tied us together. Now, and the reason why I ended up in Portland was because I was denied tenure at Hartwick College. Stan and I came in 1 year apart, and our chair suggested to us when we both were timed to go up for tenure that it isn't good for 2 people to come up at the same time from the same department. So I said, you go ahead, Stan, you go first. And so he did, and he got tenure. And then I came up, nope, no tenure. And I was, kind of, taken by surprise by that. But the reality was I had to find a new job. When you're denied tenure, it's kind of like the Scarlet Letter. I think it was Nathaniel Hawthorne, right? Big red A here. This is like DN or DT, denied tenure. Nobody wants you. And so it took a while to actually get the job at Portland State University. And when I got there, I saw not only this sign hanging over the road about Portland State University, but if you look a little further, they had this other sign that said, "Let knowledge serve the city." And so now, again, my mindset is I got to survive this one. I can't be denied tenure anymore because then you're out the door. It's done. So I decided I better do something that the university values. Nobody had done research on the vertebrates of the Portland parks and green spaces. So I decided this is a good jumping off point. This could serve as a useful tool for the city for a variety of reasons that I'll go into. So in any case, I actually started in on this project for that particular purpose. I missed some slides. Something happened there. Oh, yes. Went over it really quickly. I wanted to throw this one up. Sorry, I have to go back. This is just too good. You're all familiar with Mutt and Jeff. At least the older people are. Younger people are probably not. But this was Stan and me at Hartwick College. Okay. There's Stan, that's Mutt, and here I am, Jeff. We were, traipsing around campus all the time, this big tall guy and me, and it was a very obvious twosome that, quite frankly, the college was scared of. They were afraid of us, and so when you came up first and I came up second, they didn't want two of us around. They got rid of me. Okay, so getting back. Oh, now we're stuck. There we go. Okay, so urbanization. There are a lot of consequences of living in an urban environment. It took Stan an hour and a half to drive about 15 miles today to get to my house. Okay, that's one of lots of traffic here. But the basic problem boils down to that when you build cities, or if you extract timber or have crops, you fragment the environment and you isolate populations into the little isolated fragments that are there. In the case of all of those situations, you also create what are referred to as edge effects, which is the influence of the external environment that's able to actually extend itself into the interior of these fragments because they're now so small. Lots of surface area, lots of opportunity for heat and other factors to come in and influence what's happening there. In addition, you get in cities lots of invasive species and domestic species that people let go. Excuse me. And there are also wildlife bird conflicts. Unfortunate there, that's, I think, a barred owl that bit the dust. And on top of that, excuse me, we have building conflicts. Oftentimes, like in Chicago, big buildings, birds migrating, and you get hundreds and even thousands of birds killed in a single night. But there's also the conflicts with people's homes, which increases mortality of these individuals. They're not all bad effects. You can, in fact, have increased resources for some. We feed birds oftentimes. Some of them use garbage. So, but it does support different species that sometimes you don't want. And then, of course, there's all the pollution that is there that can affect their probabilities of survival or even interacting with each other in a normal way. For instance, sound and light pollution create considerable problems for birds because they advertise visually and auditorily. Lots of noise can create problems for them. So in any case, this is what birds have to deal with and other wildlife in the environment. Now, today's world, I looked it up today, it's 8.025 billion people in the world. Lots of us here. When I was born, it was down around 4 to 5 billion, is substantially less, okay? And associated with this massive increase of people is the growth of cities. So this is an image I took from National Geographic some years ago, I guess about 2015, and it shows megacities around the world. And what's projected to be the case in the future is that the megacities, which is defined as 10 million people or more, they're going to increase. And so, whereas in 1950, there was only one in the entire world, as of 2018, there are 33, and it's projected to be upwards of 43 by 2030. Cities are big, and they take up a huge footprint on the land. And urbanization is second leading cause of extinction of organisms in the United States. And, with the growth of the human population, just the urban population of humans is projected to be 6.5 billion by 2050. Okay, so this is a growing problem. It's not going to go away. Specifically looking at Portland, this is as of 2022, we're the 24th largest city in the United States with a population in the entire metropolitan area of about 2.5 million folks. Portland is kind of unique because it does have a lot of green space in it. Most famously, of course, is Forest Park here, which is on the order of 2,000 hectares. In other words, about 5,000 acres. I'm going to use the term hectares frequently today. A hectare is equivalent to 2.5 acres. but it's the metric units that we use for measuring area. So Portland's got a fairly large park system there. And moreover, the park system is predominantly natural areas. 68% of the park areas in Portland, Oregon is a relatively natural forest that you find. And Forest Park, big as it is, takes up 66% of that total green park space. But you'll note that all of these light green areas are parks that are scattered all around the city. So again, nobody had done some thorough surveys of the vertebrates in these parks and green spaces. So I decided this would be a useful thing to do, baseline information that we need. Now, the Portland population, I just want to show you that we're not unique. We're like the rest of the world. This is the plot of Portland population between 1990 and 2020. Okay, and you can see that it's increasing pretty steadily throughout that time, a little under 500,000 people in 1990. And when you plot out the last 4 or 5 years, we see this, and this is a consequence of COVID. It had a measurable effect on the population of Portland. Big dip, okay, but it is starting to rise again. This was just in the paper last week. Portland's population is starting to rebound. Now, just real quick with me, I'll throw a few equations at you. I know this is a Natural History Society, but you're all educated people, I can see that, so I know I can do this. If you take the logarithm of population size, which I now have here, and plot it against here, and then you do a linear regression of those points between population size and year, you get a value of the slope of this thing. Turns out to be the growth rate of the population. So if you run a linear regression between 1990 and 2020, you get a growth rate for Portland of 1.1% per year, the growth of important population at that point. And if you plug those numbers into a standard population growth equation, this one here, where future population size is equal to your starting population size, which tends to 0, you multiply growth rate raised to the power of the number of years you want to project into the future, you can make a prediction of what population size would be. And the inherent assumption here is conditions don't change, which of course is not the case. They will, but it's for heuristic purposes. We'll think about it. So if we use that growth rate and we plug it in here, starting with the population size of 1990, by 2030, it predicts 753,000 people in Portland. And at 2035, almost 800,000. And by 2040, pushing 850,000. Now, again, the assumption is conditions won't change. They will. Okay, so we're not going to hit those numbers. But the point is that the population really will continue to grow. And therefore, the need to understand the relationship between urbanization and wildlife is really, really important. So my question was really basic. What is the future for wildlife in Portland's landscape? Can we have populations of vertebrates here? And that was my specialization, but this is true for all organisms that can persist into the future. And can we provide through our research some information that might help the city plan for the future? That was the overriding goal that I had here. Okay. So real quick roadmap for what we're going to do today. First thing is, I'm going to describe for you the results of the research that I was just mentioned, a survey of the vertebrate diversity within Portland's parks and green spaces, but moreover, trying to understand what causes variation from one park to another. Secondly, I want to have a particular focus on woodpeckers and their needs themselves. The city actually came to us and asked if we'd be willing to do some research on pileated woodpeckers, because they wanted to use that as a kind of a focal species to help them make management decisions. I said, well, why not all of them? If we're going to go out there and do pileated, we might as well do all of them. And it turned out to be a very useful thing for us to do. So I'll describe that. And then the last thing is I want to go into a more detailed population level question, which is to look at the demographics of spotted towhees. Very cool bird, really, really cool bird, and a lot of fun to work with. And we came up, I think, with some results that you'll find pretty interesting. So First part of this, landscape, or I should say the variation in avian diversity amongst parks and green spaces. Now I'm focusing on birds here, but we did collect data on mammals and amphibians as well. But you can only talk about so many things at one time. So focusing on the birds. We worked in 48 different fragments, forest fragments in the parks and green spaces. And the three students who worked on this were Nathan Lichty, and why am I forgetting Robert's name? I forgot her first name. Okay, anyways, Roberts, I'll come up with it in a minute. I'm 69. Things slip away. We focused on these 48 fragments and we made decisions as to what kinds of fragments we were interested in. So these had to be forest habitats, forested parks with a closed canopy, at least 50% of the canopy closure here. And they also had to have vegetation at all levels. We're not talking manicured parks, we're talking natural parks. Within those 48 parks, we set up 279 survey points where we did surveys for these different vertebrate groups and measured the habitat variables within each of the separate parks. And then within those parks, depending upon how large they were, they had either 1 to 16 different stations where we recorded, again, habitat structure and diversity of, I should say, richness of different vertebrates. Now, this is an image. Somebody asked me where I lived in Portland. This is the West Hills. And those two are Barber Boulevard and Route 5, just to give you a little reference point for any of you who may be familiar with Portland. We collected information on the birds themselves in terms of numbers of species, et cetera. But we wanted to analyze the variation from one park to another in relation to several variables at different scales of measurement. So one of them, those scales, is what I refer to as the biogeographic variables. And this is a park we use, Maricara Park. It's about a 10-hectare park or 25 acres. And what we did was to measure the total area of each park, delimited by that red border, and then we quantified the shape. We don't need to go into it now, but there are ways of actually calculating shape because it's not only park area, but the shape of a park, which has potential influences on the number of species that you find. And then the other variable that we measure, or one of the other classes of variables that we measured, were landscape variables. And so around every one of these 48 parks, we put a 500-meter buffer around it using ArcGIS to measure a number of different habitat variables on a landscape level, such things as the percentage of this land that is covered by forest, or impenetrable surfaces like parking lots and things like that. Road density, human population density, those were all quantified within that 500-meter buffer surrounding each park. And then the third set of variables that we collected were habitat-specific variables. And so these are images of two of the parks that I worked in. And this is the kind of park that we were looking at. Again, not a manicured park, a relatively natural park, okay? And that had to have vegetation from the lowest level on up to the canopy. And so we measured shrub density, canopy cover, log snag totals, all of those sorts of things. Now, we then, before I describe that, I just want to make sure we're clear on a couple of terms here. People often use the word species diversity. And for an ecologist, species diversity is a very specific thing. And it's a combined influence of the number of species and the abundance of each species. If you're just talking numbers of species, we refer to it as species richness. And so I'm going to be talking about species richness, not diversity. But we also measured the abundance of each species. We wanted to keep the two separate and look at them individually, okay? So richness, number of species, abundance is the average number of individuals of each species of birds that we counted in each of the sample points. So have any of you ever done a point count? Yes, they're hard. They are really hard. Sounds easy. You know, you walk to a point that you've located in the forest, a randomly located point, and that's what this X represents. And then you put a 50-meter radius around that point, which you have to estimate. You know, you don't actually, every time you go out there, you don't actually measure it out. So, but we're at 50 meters out there. You walk in, you wait a couple minutes before you start to count, and then you count. You got a clipboard there, and you're listening and looking, and I've got to stand over here, sorry. As you record each bird, Oh, very good question. No, early in the day, from sunrise to about 11 o'clock in the morning, that was it. So keep it during the period of the day when the birds are active. And if it was raining, scratch it, which in Portland, a light rain's okay, heavy rain, no, can't do that. So in this case, we measured, what do I have? I can't think. Yeah, randomly located. Okay, 1 to 12 per park, and all of the rest of that there. Okay, so beginning 50-meter radius, you start counting. Okay, so you got a Steller's J right there. Now you got a clipboard and you got a circle written on that, and you record the location of that. Okay, and then we get a black-capped chickadee over there. Boom, and there's a spotted towhee there. Boom, and you got a downy woodpecker there, and then you got a Pacific wren here, and another Pacific wren up there. Now, what do we do with those two? Are they the same bird or are they not? Okay, they're far enough. Remember, this is 50 meters, and these are relatively small birds. We would probably, and this is made up, this particular image, but we would probably call those two different individuals. Okay, okay. Then we get a Pacific wren here. Well, that's really close. That's one bird. Two observations of it, but that's one bird. They're really close to each other. Okay, now we picked up, what did I just do in there? Another species, the song sparrow, I guess it was. Okay, and then we get a spotted towhee there. And again, far enough away from that guy that it's probably a different individual. Pileated woodpecker out there, we ignore that. It's outside the 50-meter radius. Okay, and then we get a Pacific wren right there. Okay, and again, those two are close enough. We've got probably the same individual. So, and then finally, another black-capped chickadee right before you ended your count. It was near that previous one, so probably one chickadee. So the final tally here is one black-capped chickadee, one downy woodpecker, two Pacific wrens, a song sparrow, two spotted towhees, and a Steller's Jay. And it sounds really easy, but it is really hard to do. You do about maybe 5, 6 of these in a day, and that's it. Okay, now, we measured all those habitat variables on the landscape level, biogeographic and habitat variables. We now have our species number or richness, and we've got abundance of each. And ultimately, we ended up finding 58 different species in the parks and green spaces. Two accipiter forms, the red-tailed hawk and Cooper's hawk were the two species. Two columbo forms, band-tailed pigeons and mourning doves. Hippotiforms, 2 hummingbird species plus fox swift, and then 5 woodpeckers, and then 46 different species of songbirds. Now, we had to take a look at that and honestly ask, are all of those legitimate representatives of the parks and green spaces? And so we had to make some assessments and judgments here, and we applied several filters here to pare this down. And we ended up eliminating the raptors. We only had 2 species, and neither of them forage. Well, the red-tailed hawk doesn't forage inside the forest. And we got few enough detections of Cooper's hawks that they really weren't worth the analysis. And moreover, Cooper's hawks, if you watch their behavior, will frequently leave their park and they'll move to other parks to forage too. And red-tailed hawks would do the same thing. In the case of aerial foragers, in this case, the violet green swallow here, they forage above the forest. They don't forage inside of it. Okay, so that's not relevant. The measurements we were taking were not particularly relevant for them. And then the third group we eliminated were things that we called rare species. A rare species was one in which the average abundance, when you average it over all parks, did not differ from 0. So they're just very uncommon. And most of the reason for a rare species was that it was the wrong kind of habitat, and it was picked up near a habitat edge. So these are all of the rare species that we eliminated here. Common ravens, okay, and we've got white-breasted nuthatches. These are oak specialists, okay? We weren't working in oak forest, okay? And then we get evening grosbeaks, red-winged blackbirds, wrong habitat, okay? Common yellowthroat, wrong habitat, and I could go on here. But all of these ended up with an average abundance not different from 0, and therefore we took them out of the analysis. So we were left with, okay, 41 species distributed as so. So the following analyses are based on that more restricted data set. So what do we have? Well, one thing I haven't mentioned yet is that we made the decision to look at this in a more structured way, where we brought in migratory behavior. We had a sense that migratory behavior might have an influence on the results. And as I'll show you in a moment, it did. It was huge. So amongst the resident species, they're the most common group. 20 species of the 41 were resident, meaning that they are there year round. We have short distance partial migrants, 8 of those. They are species which move a little way out of the study area, but they stay within North America, north of the US-Mexico border. The long distance migrants, which were the second most common group, they leave the United States and they go farther south, most of them to South America. So the analyses that I'll present separate those groups. Now, who were the residents? Well, here's our most abundant bird in the Portland parks and green spaces, song sparrows, followed closely by spotted towhees. Okay. And I'll read down the list real quickly: black-capped chickadee, Bewick's wren, house finch, Steller's jay, American crow, brown creeper, red-breasted nuthatch, Pacific wren, chestnut-backed chickadee, bush tit, northern flicker, downy woodpecker, Anna's hummingbird, Hutton's vireo, dark-eyed jonquil, Cassin's, California scrub jay, hairy woodpecker, pilly woodpecker. Okay, those are our residents. The most abundant short distance migrant was by far the American robin. And then when we get over to the migrants, you'll note much less abundant than the residents or even many of those short distance migrants. But the black-headed grosbeak was the most abundant migrant in the long distance migrant in the parks and green spaces. And they were followed by Swainson's thrush, black-throated gray warblers, western tanager, Pacific slope flycatcher, Wilson's warbler, western wood pewee, band-tailed pigeon, orange-crowned warbler, rufous hummingbird, warbling vireo, Cassin's vireo, and olive-sided flycatcher. So a nice set of species. You can see these things in the parks right down, well, close to the downtown Portland. When it came to, there we go, looking at what drove variation in richness, again, I separated the different migratory groups to look at it. And when you look at the residents, and again, I've looked at their variation, and I want to emphasize each point is the number of species within an individual park. Each of these points represents one park. So there are 48 of them there. And it turned out that the most important factor explaining variation in the abundance or the number of resident bird species was not how big the park it was. And that wasn't its shape. It didn't matter what was around it. It was the abundance of small native tree species. That was the most important factor influencing the number of resident species that you find. And as it turned out, that was also, maybe it's not surprising, one of the other important factors explaining variation in the abundance of them. Not only the number of species, but the abundance of them, total numbers seen. Okay, but the more important variable is actually the size of the park. And it might seem surprising, but small parks were better for resident bird species. I didn't expect this. That was totally out of the blue. Okay. Why? Well, let's look at some of the individual species. So here are 4 species. The x-axis in all 4 cases is park area. They've been transformed to conform to statistical assumptions, but just look at it as going from small to large parks. American crow, Bewick's wren, spotted towhees, and song sparrows, all of them showed a decline with an increasing size of the park. And I believe the reason for this is that these birds simply don't like the interior core of really large, they like edges. You know, think about where you find Bewick's wrens and where you find American crows. I mean, they're along edges. It's not in the middle of a park. So big parks don't really matter for them. With respect to the... There's no place for non-edge species to be in an urban environment? Oh, there is for sure. Pacific wrens, for instance. Okay. Yeah, that's a glaring example of a resident bird, which takes a completely different response. Okay. Yeah, there definitely is. So there is value. Oh, absolutely. No question about it. Especially when you look at the long distance migrants, which is what we're looking at here. So this is the number of long distance migrant species you find in parks in relation to how large they are. And again, this is a transformed variable to conform to statistical assumptions. You can see that there's a very strong statistical relationship there, increasing and then kind of slowing down. You get to really, really large sizes. So this would be Forest Park out there. So they increase the number of species as park area increases, and moreover, the abundance, the total abundance goes up linearly as park area increases. Long distance migrants absolutely need large parks in order for them to be present in the urban landscape. And interestingly over here, we find out that migrants also respond to habitat variables, but in this case, it's the ground cover. And this is an axis of variation, which is the combined effect of 2 factors. the number of shrub cover, the amount of shrub cover in the 0 to 1 high category, and English ivy. So if you're out over here, you've got little shrub cover and you got a lot of ivy. If you're over there, you have very little ivy and you've got a lot of shrub cover. And that's where you see the highest abundance of the migrant birds. Okay, they don't like ivy and they like a lot of shrubs at the low levels. Okay. Some examples. Again, 4 of them. Here's our Pacific wren, which is a resident bird species. I had to throw this in, and you'll see that they're virtually, well, they are never found below a park of this particular size shown by the dashed line there. That's 10 hectares or 25 acres. Never did we find a Pacific wren in a park below 10 hectares. But as soon as you get to that point, they just keep going up and up and up. Same thing over here with the Pacific slope flycatcher. Never found in a park below 10 hectares. Then as soon as you get to that point, they absolutely do go up. And same thing over here with Wilson's warbler and Swainson's thrush. So 10 hectares emerged as a kind of a critical size below which you lost a whole lot of long distance migrants, and you would have lost at least one resident, the Pacific wren. So what will all this tell us? Well, first of all, with the resident birds, we can conclude that park size is not very important for them. What's most important is the habitat structure within the parks themselves. Okay. With respect to the long distance migrants, in this case, species richness and abundance increase directly with park size. So the bigger the park, the better it is for long distance migrants. If you want to see a Pacific slope flycatcher, Swainson's thrush, Wilson's warbler, you got to have big parks out there. But their abundance was also affected by habitat structure again. And then this 10 hectare minimum size emerged. And I want to emphasize, I didn't know this coming in, but after I found this, I started looking through the literature and I found 2 other references, one from Eastern North America and one from China, where 10 hectares was identified as a critical size where you saw the increase in a number of forest-dependent species. With respect to short-distance migrants, there wasn't a whole lot there. All we found was that they tend to be, unexpectedly, more abundant closer to the city. Robins, that's the most abundant. That's what probably drove this, robins, and they like lawns. So maybe that explains what that's all about. So we came out of that, I think, with some important conclusions. And I've actually subsequently found that the city of Portland, after I gave a presentation to them, began to incorporate this 10 hectare size into their management plans, which I think is a really great idea. And I felt like, okay, you did something useful in your career, right? At least one thing, okay? But we didn't sample woodpeckers well. And as I mentioned earlier, the city came to us and they said, hey, what can you tell us about hairy woodpecker? I mean, pileated woodpeckers. And I responded, well, let's do them all. And so we decided to do that. And the student who did this, his name was Adam Boz. He kind of, well, he did all of the field work on this. And he became interested in it from working with the city, and he got me excited about it. And the reason why woodpeckers become kind of important to understand what drives their abundance is because they are what are referred to as ecological engineers. And some folks refer to them as keystone species. And it's because of all of their activities which create habitat for other creatures. Over 300 species of, in total, vertebrates and invertebrates have been found to utilize cavities constructed by woodpeckers. So if you build habitats or you manage habitats that favor them, you're going to benefit a lot of other things as well. And they are also larger than most passerines. And so maybe they have some different needs that passerines do. And so I felt it was worth taking a deeper look at this. This, I wanted to emphasize, everybody here knows what a pileated woodpecker is, and they forage on logs or snags, which are standing dead trees, but they also forage on logs on the ground. And you can see a huge excavation by pileated woodpecker on the ground, and this guy too is close to the ground. So logs and snags become probably very important for them. The eastern United States has been beset by the ash borer, and it's killed just untold numbers of ashes. So a couple of years ago, I was in New York, and I saw a pileated woodpecker fly up to this tree which was completely closed. In 5 minutes, there's a quarter there for just a point of reference for size. In 5 minutes, that bird had opened this tree up. And you can see the cavities of carpenter ants that it was after. So they can find these resources and open up the logs and snags that a lot of other species can use. And in addition, not all woodpeckers rely on excavating insects for food. You get things like Lewis's woodpecker, which is a flycatcher, and you get sapsuckers, which of course build wells. And these wells, this was an aspect of their keystone species ecological engineering moniker. Here is a hummingbird sampling wells created by probably, well, a sapsucker of some species, I'm not sure which one. But nonetheless, I think you can get the point that they are potentially very important species to have within an environment. So in this case, we worked in 36 different parks. Some of them overlapped with the ones from the previous study, about half of them, and then others were new. We have 6 species of hummingbirds, woodpeckers that live in the city. 5 of them are relatively common. The acorn woodpecker over here in the upper right is an oak specialist. And so we did not include this one. We never recorded them in any of our analyses because of its specific habitat needs. But the other 5 formed a nice graded series from the 27-gram downy woodpecker on up to the 300+ gram pileated woodpecker. So a wide range of sizes and ecological types are here. We conducted the same basic set of analyses that we did before. I won't go into the details of that right now. But one of the things that we really wanted to figure out was what are their minimum area requirements? Okay, MAR here, that's what MAR is, minimum area requirements. And a guy named Chandler Robbins came up with this way of attempting to assess that. So imagine you've got a bunch of parks that you're looking at from very small to very large, and you're going out there and you're surveying for birds, and you don't pick up any below this size. And at that point, you start picking them up, but you probably not 100% of the time. Occasionally you see them, but as park area grows, the probability of detecting an individual keeps going up steadily until it gets to a point where 100% of the time you go to a park that size, you're going to have that species there. What Chandler Robbins suggested was that half of that point, half of the 100% probability of occurrence right here, halfway to that point, would be the minimum area requirement, because only 50% of the time do you find it there. So it's basically coin toss. So that seemed, and I think is reasonable, a logical place to identify what would be a minimum area requirement for a species. So when we did this for our 36 parks, for northern flickers, they had a ridiculously small minimum area requirement of only 0.6 hectares. Now I want to emphasize, a hectare is 100 meters by 100 meters. Not that big, really not that big. And they needed only 60% of that in order to be found 50% of the time. Okay. Downy woodpeckers, a little bit bigger, about 1.3 hectares was the point where 50% of the time you find them. Red-breasted sapsuckers, up to 8 hectares. And once we got into the hairy woodpecker, we're up to, hold it, here we go. Well, that's not the direction I want to go. Hairy woodpecker, okay, 35 hectares, and then the pileated woodpecker, we're up to 51. So what this means is that, again, we'll just call it 50 for the sake of argument here. You have to have a park that's at least 50 hectares in size to have a 50-50 chance of seeing that species there. That's what that's all about. And if you remember, these form a nice graded series in terms of body size. The differences amongst them relate very nicely to how large they are. And this makes a lot of sense. Big birds need a larger area. But the one that was really an anomaly was the northern flicker. For its size, a ridiculously small minimum area requirement.
Mike, could you pick up your mic?
Oh, yeah, sorry. Yeah, so yeah, the northern flicker turns out to have a ridiculously small minimum area requirement for how large it is. Now, I got a lot of birders out here. So I'm going to ask you, where do you commonly find flickers foraging? On the ground. They're specialists on ants that live in the ground. And I can tell you from personal experience in my driveway, they are frequently found foraging in spaces like this. Okay, they don't need trees beyond a few here and there in order to nest in. They don't forage on trees. They build cavities in trees to nest in, but they don't forage from them. All righty. Now, one of the things that Adam did, and this is his idea independently of me altogether, was to examine the differences in the abundance of woodpeckers between natural parks that I've been talking about and manicured parks like this. So he incorporated 29 and 7 of these different parks into his study. And I want to emphasize that he conducted the same vegetation analysis here, and manicured parks and natural parks did not differ in any way when it respect to trees. Same total basal area, which represents the size of the trees, same canopy cover, all of that was the same. The obvious difference is the understory. That's really different. A lot of people see these parks and think, oh, that's not bad. Birds could live there. Well, not woodpeckers. The only one that was found there in the same abundance as they're found in the natural parks was our friend, the northern flicker. Every other species, and pileated woodpeckers were never found there. But for these other 3, these represent 95% confidence intervals. And if they actually come down and strike this line down here, it means it's not different from 0. So boom, not different from 0, not different from 0. And again, not even found and not different from 0. And significantly larger in the natural parks. So right off the top, we could say that these manicured parks are a desert for woodpeckers. They just don't work. So the 2 species that we were really most interested in were the hairy woodpecker and the pileated woodpecker. These are the most forest-dependent species with minimum area requirements of 35 and 50 hectares. We wanted to look at that in more detail. We did this for all of them, but I'm only going to talk about these 2 because they're the most forest dependent of the 5 species. And I've talked about the landscape variables. We examined them in relation to this, did the same sort of statistical analyses. A plus or a minus means that we expect abundance to increase with these variables and to decrease with those. A bunch of landscape variables, a bunch of habitat variables, again, similar to what we did before. And again, positive means we expect woodpeckers to go up as the total basal area of trees go up. We expect woodpecker abundance to go up as we get more snags and logs. All right. What do we find? Well, when it came to the hairy woodpecker, we found that park difference, that was the most important variable explaining differences in the abundance of hairy woodpeckers, whether it was a manicured or a natural park. And they're more abundant, obviously, in the natural park. Park area had a positive influence. The bigger the park, the more hairy woodpeckers you're likely to see, more canopy cover, and more logs you find, more hairy woodpeckers. Interestingly, it's not snags, it's logs. Kind of took me by surprise. That's kind of the fun part about research. Lots of times you get surprised. Pileated woodpeckers, turns out, park area is the most important. And again, given how large they are in comparison to all of the other species, that's not surprising. But what we have here is what we call a second order polynomial, which means this is the way abundance varies with park area. It flattens out. It hits an asymptote once you reach a particular size. The other factors that came into play were shrub density. They like the understory, got to have it. Importance value of deciduous trees. They prefer deciduous forest over coniferous forest, or at least forests that are dominated by angiosperms compared to conifers. And then the amount of forest in the landscape. So for each individual park, remember we had a 500-meter buffer that we measured the amount of forest around it. Pileated woodpeckers like parks with lots of forest around them, as well as within the forest. Okay. So if the goal, and this is what the city's goal is, to try and manage forest for forest-dependent species, our 2 species, the hairy woodpecker and the pileated, I think give us a good sense what forest-dependent birds really require. And it really comes down to this. You have to have large parks, and it's better to have them embedded in a forested landscape. Okay, it really makes total sense, but at least we could quantify it to establish that. And honestly, for management decisions, you got to have solid data like that in order to convince people to do it. So here's an image from somewhere around 2020, 2022 of Portland. Here's the west side where I live. Here's the east side where my daughter lives. Amount of tree cover, canopy cover that you find. Very large over here, very little over here. Okay. These are questions of social justice as well. I mean, this is not just a bird thing. This is about what the people have available to them. I live over in here, man. I got gravy. This is good stuff. My daughter lives over here. It's different. And it's bad for the birds as well. Okay, so large forested landscapes are important. And then we need to have forests in the understory that are full of shrubs and small trees and a full canopy. Now, this works for woodpeckers, but honestly, I think that we can use them as a tool to guide us for a whole bunch of different species. These are important, for instance, ground cover, thick ground cover, and litter in the forest, and logs on the ground, and satina, plethodon, and salamander. They love that kind of stuff. They got to have that. You got bewick's wrens over here. They love lots of scrubby, scrappy stuff on the ground. Okay, Western screech owls and cavities built by pileated woodpeckers, Swainson's thrushes, they like thick understory over there. And then you get flying squirrels and Douglas squirrels over there. They all rely upon resources that woodpeckers construct, these cavities, right? So if we use the woodpeckers, I think we actually cover a whole slew of other species and protect their habitats. Okay, I never even looked at the time when I started, so I don't know how long I've been here. Okay, thanks. So I want to switch gears a little bit. Everything I've been talking about right now has been at the community level. Okay? And we're simply looking at species, whether they're found there or not, and how abundant they are. But we're not getting down to what I consider the nitty gritty and the real heart and soul of ecology, which I think is population biology. Because in population biology, we look at births and deaths, the vital rates. And that's what ultimately determines lambda, the little symbol right up there, which is population growth rate. And that's what determines whether or not you're going to have a species present at a park. Can it sustain itself through the birth and death rates that it expresses in that particular habitat? Now, I decided to work on spotted towhees. I could tell you a real interesting story, but I might embarrass the student who story's about why we chose towhees, but it turned out to be a really good decision. These are the second most abundant bird in the city. Now, when we look at the biology of birds in terms of their full annual cycle, one of the things we have recognized for many years is that there are three essential activities that birds must accomplish in order for them to persist in this world. And the first is to survive the bad conditions. So in the Northern Hemisphere, the winter months are tough and birds either migrate or they hang in here and survive the conditions, the harsh conditions of the wintertime. Once they've survived that, then they go into their breeding season. Okay. And the breedings, and these are, I should take a step back. These are standard images that Cornell University and the birds of the world use to describe the annual cycle of birds. And so you've got the months on the outside. This first bar here refers to when migration occurs. Okay. This inner bar here refers to reproductive activity. And in this case, when they have eggs, when they have nestlings. And then this inner portion refers to molt. When during the year do they molt, replace their feathers? And virtually all birds every year replace all of the feathers on their body. They're energetically demanding. You can't do them at the same time. So they separate them out. So what I want to focus on is this breeding portion, but it does ultimately end up incorporating the full annual cycle. Okay, now the question, and I've had this for years. You look at a population, you see it there every year. You think they're producing enough young to replace the individuals that die. And that's what we would call a self-sustaining population. But that's not necessarily the case. This could be a population where reproduction is actually insufficient to counter the number of deaths they occur. But if they get enough immigrants coming in, they can maintain a continual presence on that landscape. And we just haven't figured this out for any species of bird in Portland and many other places, whether or not it's immigration or local reproduction, which actually sustains the population. And that's the question we were after. Are these populations self-sustaining? Can recruitment offset mortality? And recruitment is the entry of brand new individuals into a population. So this study, question? This study was conducted primarily by Sarah Smith and Jenny McKay, and then a third student who's not in this image right here, Jen Richardson. They were my three towhee gales, and they did a bang up job. Man, I got to tell you, I love finding nests. I just absolutely love it. And so when we got to this and we're going to be working on towhees, I thought, well, this is cool. They nest on the ground. This should be relatively easy. Was I wrong? It was the hardest nest I've ever attempted to find. I think I found two myself. Sarah and the others, they found over 350. Yeah, they worked their asses off. They really did a great job. In any case, they worked for 3 years on this project, and they not only found over 350 nests, they also individually marked 265 adults to actually look at survivorship from 1 year to the next. Very detailed study. Okay. Now, why towhees? Well, several reasons. One, they're cool. Okay. Secondly, they're abundant. It's the second most abundant species in a resident species. Well, actually, second most abundant overall in the Portland landscape. If they can't sustain themselves, probably no bird can. So we thought we'd find one where it'd be a good, solid test of this. And moreover, they're abundant in this, mid-size range where most of the parks actually reside in terms of their total area. In addition to that, we can distinguish the two sexes and two age classes based upon plumage. And if you're doing demographic work, it's really nice to be able to know, is that a male or is that a female? Is it a young bird or is it an older bird? And based upon plumage, we can do that. So if you look at that bird up there, that's a male that's in at least his second breeding season. And you can tell that because of that dark sheen and a dark black hood that he's got and the really bright red eye. This is a female in her first breeding season. And you know, because she's very brown and a dull red eye. And older females and younger males are in between these two. And you can generally separate them as well. A little trickier, but it can be done. Okay, the other reason we chose them is that they are resident. They're there year round. We can keep track of them. They're highly territorial, and they are actually relatively easily captured. I work with kingbirds. That's my other major group of organisms to work with. They're murderous to capture. And these guys were just a relief. Put up a net, and you put up a little taxidermic mound of a towhee, you put a playback up, and boom, they hit the net and you got them. Okay. And as I told you, they're ground nesters, which initially I thought was good, turned out to be really bad for me. Okay, so we didn't use huge numbers of parks. We settled on 4 parks to work in, and I'm showing them right here. Maricara Park is the one up there in the upper right. And then we have this is West Portland Park here. This is Lesser Park. And then we have in Lake Oswego, we have Springbrook Park at 24 hectares. Notice that they're all pretty close to each other. Maximum distance is 3 kilometers from one park to another. Now, the reason why I chose this site is partly because they were good-sized parks located relatively close to one another. But that red dot there, you see that? That's where I live. I made it easy for me. It's okay, I'm old, right? They're all young. So I made it easier for me to get to these parks. Now, in each of these parks, I want to emphasize, we measured adult-specific survival. Okay, marked birds in all 4 parks were annually surveyed to determine how many survived from one year to the next. We also measured total seasonal production of young by individually marked females. So we could track them across the entire breeding season. And I'm going to go into that in a moment. This is a bear to do. And then we also measured, well, I should say we estimated first year juvenile survival. Now, these are the 3 variables that need to be plugged into this equation for growth rate. Remember, I talked about growth rate of the Portland population. This is the same variable right here. You can calculate growth rate in different ways. Okay, in this case, growth rate is equal to adult survivorship plus this is recruitment of new individuals. And it's the production of offspring multiplied by their probability of surviving from the point of independence to their first year. We divide this by 2 total number of young produced because population models are female based. And so we only want to look at half the number of young because that represents the number of females that were out there. So if you have a lambda equal to 1, it's stable. Less than 1, it's going down. Greater than 1, it's going to increase. It's pretty simple. It's actually quite simple in theory. Okay. All right. So how do you calculate seasonal production? I think it's important sometimes to take a few moments to actually delve into the details of how some of these variables are collected, if for no other reason to let you know how hard these students worked. They really did. So for a towhee, they lay 3 or 4 eggs, so about 4, and 1 a day. So egg laying and incubation require a total of about 17 days. Once they get into and there's a female towhee there sitting on a nest. Once they get into the nestling period, you got 4 little towhee nestlings right there. They usually fledge about 11 days of age. As early as 8, but often up to, not uncommonly, up to 12. Okay. I'm always just absolutely amazed by this. You think about it. You've got an egg that was laid. It goes through about 2 weeks of incubation, produces a hatchling. In 8 days, that hatchling, if you disturb that nest, will jump out of that nest and run like hell. And you're going to have a hard time keeping up with it. In just 8 days of development. It's phenomenal. They grow so fast. All right. Now, once they leave the nest, then they stay with the parents for about 30 days, where the parents feed them with decreasing frequency as they develop their skills at foraging. Okay, and then they've got, depending upon where in the season they fledge, they got anywhere between 260 and 300 days to survive before they get to their first breeding season. And so with each one of these, we've got a survival probability. That's what S0 to S3 reflects, a probability of surviving that phase and transitioning to the next. Okay. So if you want to know, and the total nest cycle takes 58 days. The breeding season is actually 140 days. So there's room to produce more than one brood, and they do. Okay? But in order to document that, you have to be out there and you have to find their nests. And so this is really what it looks like. For every female out there, my graduate students track them through up to 3 successive broods. I just can't emphasize how much work that is. It really is. If they fail, well, then they build another nest and they'll try and get those guys out. So potentially, even though 58, call it 60, times 3 is 180, way beyond the actual length of the breeding season, they're able to sometimes get in as many as 3 successful broods because they overlap them. Okay? Dad will take care of the fledglings towards the end of that period, and mom goes back and builds another nest and starts laying eggs in it. And so on average, even though they can produce up to 3 broods, the average was 1.4 broods per female, successful broods per season. Getting to that point, though, required a lot of work. So what do we find out real quickly here? Springbrook Park sucked. Okay, it was not a place you wanted to be. It had lower total season production of young than either West Portland Park or Lesser Park. It didn't differ from Maricara, but it tended to be lower. Okay, but those other 3 did not differ. If they share the same letter, it means that they're not different from one another. But there was park differences in total fecundity, total season fecundity, but not with respect to adult survivorship. Okay, so again, the average survivorship, 95% confidence interval, and they all overlap. So no difference in adult survivorship from one park to another. A little better than a coin toss, but still not very good. So we put those 2 variables together, adult survivorship. It's kind of, can I get rid of that? Well, you can kind of see it up here. SJ times F divided by 2. Yep, right. So that's what we have. We have that. I just showed you that. F divided by 2. I just showed you that. SJ, I'm not going to go into the details of how we estimated. If anybody wants me to talk about it, I will later, but we estimated it was about 0.262, which meant that about 26% of the young which reached independence survived to their first breeding season. And when you do that for all of these 4 different parks, 3 of them fall below a value of 1, which means they are going down. Okay. Only one of them, West Portland Park, had a positive growth rate, indicating they could actually grow on a continuous level. They're doing actually quite well there. But one of my other students, who I haven't mentioned yet, Amy Shipley, she was the person who conducted research on their survivorship over the 30-day period after they leave the nest. And she did that by way of radio telemetry. Okay, so you put a little radio transmitter on their back with a figure-8 loop going around each leg. It's got a long antenna, which you can see here. And she went out every day and located the 52, I think it was 52 different fledglings that she attached these transmitters to document their survival. One of the cool things about this is that if a bird is killed, you can find the radio transmitter if it's intact. And they were all intact. She lost 16 of the 52 birds to predators over the course of her study. And we were able to, isn't that ghastly? I mean, look at it large as it is here. That's pretty ghastly. Wow. But you can see also the bands that we put on the leg for the birds there to identify them. So in any case, there's Amy with her antenna. 52 birds followed for their survivorship over that 30-day period. And it turned out that of the 16 deaths, we couldn't figure out why 4 of them died. You know, it just was no smoking gun that told us this was the probable reason. But we did for the other, what would that be? The other 12 birds, we were able to figure out with pretty high confidence. For instance, Western screech owl, we found radio transmitters right below the tree with a Western screech owl nest in it. That's what took it. Okay, so 5 of them were lost there. Only one to an accipiter, Cooper's hawk. We found that one below the nest of a Cooper's hawk. And then we found 6 others in driveways, in backyards, and in a couple of cases with the cat sitting over it. So the majority, although close to Western screech owls, this was the major cause of death in the post-fledging period for towhees. Big figure, 38% of the guys were killed by them. So this is what I just showed you, where we had an SJ, juvenile survivorship, of 0.262. That value included the losses to cats. So what would happen if we actually didn't have any cat predation? And we had what's referred to as additive mortality, which, if you want, I'll talk about that. But if we eliminate it during that period, the survivorship of the towhees increases from 0.645 to 0.808. It's a big difference. And, honestly, the question becomes, is that a realistic figure? Could it be? And the answer to that is a resounding yes, because there was another study by some other folks up in Seattle going on at the same time. They marked even more towhees than we found. And I spoke to the author, and she said they had no cat predation. And their survival during that time period, 0.835. Okay, pretty damn close. Okay, so if I go and use that figure instead of 0.262, turns out that my survivorship from the point of independence to their first breeding season goes up to 0.326. Almost a third of them make it to their first breeding season. And if you look at their growth rate, you find that 3 of the 4 are equal to or greater than 1. So statistically speaking, this is not different from 1. That's a 95% confidence interval. The other 2 are well above 1, indicating that those are growing populations. Only one, springbok, still maintained a declining population after we removed the effects of cats. Something about springbok. I think, to be honest with you, I think it was because it was the most developed of the 4 parks. It had trails that were extremely wide, heavily used by people in the neighborhood. And I think that's probably the 3. And they would walk pets through there. So the probable explanation is that. So what I think that what we have going on here with the towhees is what ecologists call a source sink system. We've got 3 parks, certainly 2 and probably 3, where you're producing in excess of young. You got 1 park here where we clearly aren't producing enough to sustain the population. So over here, they fill the environment up. What do the extra individuals do? Well, they probably leave and they end up in places like this where there's available space because they are below a growth rate of 1, meaning they're declining, and they help sustain those populations there. So this is likely the case, I would suspect, for a good many of the birds that are there. And source sink systems if you got enough sources around, you can maintain a population where even some of them can't reproduce enough to replace, but they pick up the excess from the others that are really doing well. So, can urban birds populations be sustaining? Yeah, I think unquestionably they can be, if we provide the appropriate conditions. And in the case of towhees and probably other ground foraging birds like song sparrows and juncos, keeping cats out of the picture is real important. It's really, really important. Okay? And there are probably other species are going to have their specific habitat needs. But the point is, if we study them and we learn what those needs are, we can then set the conditions that will allow them to grow. I had to throw this in. I was walking through a neighborhood once. I don't know if you can make out what this is. This is a little metal sculpture here. Okay, here's a cat. Here's a bird bath. And there's the bird that the cat is swatting at. What sick individual produces that? Okay, so take-home messages here. First is, with respect to forest-dependent birds, park size matters. It really does. Big parks are better. There's just no question about it. And this is especially true for the long-distance migrants. If you want to have long-distance migrants around in the Portland urban landscape, you got to have big parks. You're not going to find them nesting in your backyard. But it's also important to maintain important habitat features inside these large parks. They can't be degraded. You got to maintain good structure for all of those there. And these include things like shrub cover and coarse woody debris and all that. Landscape factors were really not that important for most species. They were for pileated woodpeckers, but for most species, the landscape surrounding the park really wasn't all that important, which is, again, I found that confusing. But I think the explanation for that is that Portland has a very high tree canopy structure spread throughout the forest. Where I live, it's 40% or greater of the land surface is actually covered by trees. On the east side, it's less, about 20%, but research and other systems have shown when you get up around 25 to 30% canopy cover for an area, that's really sufficient for most of these forest-dependent birds to move from one location to another. If I'd conducted more work on the east side, it might have been a different story. But I think that's the explanation for why the landscape is less important. And then returning to this size thing, as I described before, 10 hectares emerged for a number of species as a critical point below which they were gone. And many of them had these minimum area requirements of 30 hectares or more, big parks. So the problem, how do I want to put this? Let me say, is that when we look at those numbers, we have to make a decision, like 10 hectares. Is that the size park that Portland Metro should be looking for in order to establish a solid, longstanding network of parks that will support these animals? And really, it isn't. This is, remember, it's minimum area requirement. And those minimum area requirements really represent what ecologists refer to as a tipping point. Okay, this is a point where it's of instability, because as soon as you kind of tip just a little bit this way, boom, they're going to go down. And so what you really need to have is a mindset that, again, this is the minimum and I should be striving for more. Try and get more if you can. Okay, it's really important. Now, all of that, in a sense, in the existing Portland landscape is irrelevant, because the parks are already there and the other lands are already taken up for some other use. So we can't really change the current landscape to accommodate these potential needs. So I think its value is in the future. Now, as we move down the road and the city continues to grow, we need to think proactively about establishing parks in the outer rim that are large so that we can sustain the populations inside of that. So it's future planning, I think, which is hopefully be the greatest benefit of the research that we have done here. And the other important point here is that the majority of the land in the city is residential. It's not parks by any means. I mean, in this image here, the white are the parks, and the tan color is all commercial and industrial, and the green is where people live. That's the majority of the landscape. And I think at this point, we now begin to consider the possibility that maybe there's something that each one of us can individually do in order to promote diversity of organisms in the landscape. Now, most residential homes, Portland's not bad, but in a lot of places you go, this is all you got. This is a biological desert. Robins like this, but I don't know any other bird. A flicker now and then, but very few bird species are going to be foraging out here. There's just nothing there for them. And forget about salamanders. Forget about chipmunks, and they don't like that kind of stuff. Okay. My wife, right there, she tuned me into this book by Douglas Ptolemy about nature, entitled Nature's Best Hope. And what he's talking about at this point is trying to change the mindset of people to move away from the nicely manicured lawns and to develop more natural lawns into what he has referred to as the homegrown national park. Each one of us can do these sorts of things where we can modify our home environment to make it more hospitable to wildlife. And just as an example, I'll show you my yard. This is a view outside my bedroom window, our bedroom window, okay? We had lawn when we moved in, and we kept the lawn for a number of years. And then we decided to replace it. And we've got, for instance, here, bleeding heart. We've got salal here and down here. I got sword ferns. You can see them scattered about there. And these are rhododendrons, azaleas. And there are some, forgotten the name of the species. I always forget it. There's a flowering currant right there. We planted it in native species. This is about 2 years after we made our initial change. This was yesterday. I took this photo. I've since added cover objects here, rocks over there. Notice the leaves are on the ground. Don't move them. Keep them there. Okay. Critters like that. That supports insects, food for vertebrates. Okay. And imagine this is my neighborhood. Okay. And all of these are home streets here, individual homes. That's my home right there. We'll just call it. It's an isolated little spot. I know maybe 2 other people in our neighborhood who've kind of done the same thing, but they're quite a distance from me. So our yard's pretty isolated. But I'll tell you, within 2 years of starting this little project, those 3 species nested in that front yard. Within 2 years, 2. Spotted towhees, song sparrows, and juncos nested in our front yard. Okay. Now imagine if my yard wasn't isolated. Okay. Not everybody has to do this, but if we could get a bunch of these together, think about what wildlife might look like in your neighborhood. Not only the vertebrates, you're going to pick up a lot of inverts too, butterflies, bees, and dragonflies. And I want to emphasize more than birds too. I've already talked about the birds, but Douglas squirrel, we've had them in our yard. We've got plethodon and salamander and ensatina. I'm bragging to the people that I ate dinner with today. Last spring, I found 5 gravid female ensatina in our yard. Okay. This is something that we all have the capability. It's not easy. It really isn't, but it's possible. And, I think we've enjoyed doing it. So what I want to emphasize, the power of collective individual action. We do this. We don't need to depend on government to do it for us. We do these things, and we're going to develop habitats that are much more favorable to wildlife living around us on a daily basis. So I want to thank you, and any questions, I'd be happy to take them.
If someone asks a question, can you repeat
Yes.
the question for the?
Yeah.
Yeah.
Sure enough. Yes.
Just a real simple question. What is it about inside that is
What is the what?
What is it about English ivy?
So the question is, what is it about English ivy that causes problems for animals? I think it's the dense cover. It just smothers everything else. Native vegetation is gone. It's just completely covered by it, and it's really thick and hard to move through. Yeah. And I honestly never see anything eat ivy. I don't find leaves. Yeah, and so I don't think they provide food for the animals that are there either.
I have berries.
Yeah. Yes.
I was wondering about the source sink idea. If birds go into the sink, are those birds that probably wouldn't and so it's, like, I'm wondering, does it cause it drain on the population and that those birds might have gone someplace where they would have a higher probability of success?
Okay, so I'm going to try and paraphrase. So the question was, correct me if I don't get it right. The question was, birds that are in sources, if they move to other places that are sinks, are they going to, how do we want to say it?
Yeah, is that part like actually a detriment, or would the birds
Okay,
possibly have
okay.
died?
I think it's beneficial because, for instance, Springbrook Park, the survivorship of the adults was the same as in the other parks. It was their reproduction that was really poor. And so it provides a livable space. It may not be great for reproduction, but they can survive there. And so once they've survived, then, and some of them will reproduce successfully, but in the coming years, if they survive, they can also move to another location. So it could be, for some individuals, be a temporary stopover before they find a better spot in which to breed.
The shape of a park made a difference. I know I'm familiar with Tryon Creek, Portland, and it's a long, skinny one. Does the shape make a difference?
For most species, it didn't. But for a few species, it did. And it was always a park that was rounder or squarer rather than long and skinny. Long and skinny was not a good thing. There were, I don't remember which species they were, I'm sorry, but there were a couple of species that showed a negative relationship with a shape that was long and skinny.
I've got a question here online. It says, does anyone have any suggestions for how to humanely keep cats out of small park spaces?
Yeah. Bob Salinger, who just died recently, the question was, are there ways in which to keep cats, domestic cats, out of small parks where they can, create trouble? Well, one is to come to grips with the fact that cats just don't need to go outside. Right. They just don't. My brother has cats. They never go outside. They're plenty happy. Okay. They don't. It's how humans treat them. I have nothing against cats, but allowing cats to roam free is a bad idea, not only for wildlife, but for cats. The lifespan of a cat that's outdoors is about 2 years. If you're indoors, it's like in the teens. So Bob, and other than just keeping them inside, Bob Salinger came up with this idea of called a cataport, I think it was. Catio, right. Where you build on your house an outside structure which is screened in, and it might extend the entire length of your house in the back, but you can let your cat out there and it can go outside if it wants, but it just can't roam free. Okay. In my neighborhood, it's a joke. We've got coyotes, and I was walking through the neighborhood in the last couple of weeks, 3 different posters up for 3 different missing cats. Well, we know where they are. Okay.
The bird lovers though.
Yes.
Oh, I just wanted to say, I love that you brought up the residential habitat, because we have a program here through Lane Audubon called Habitat Haven.
Okay.
Come to your yard and we help you figure out what native plants to plant and how to develop habitat.
Very good. Okay. If you didn't hear that, I've forgotten your name. I'm sorry. Barbara mentioned that Lane Audubon has a program to actually help develop, build your yards into a more natural landscape that would actually help support wildlife. Portland Audubon has a similar program as well.
Barbara's shy, but we've been doing 1 year, not even a year, 70 people want to do that. That's fact.
That's great. That is great. Yep. Good job. I had this one first. Okay.
In East Portland, does Mount Tabor offer much good habitat?
It does. It was one of the 48 sites that we used. And it's a pretty large park, good habitat. And yeah, it supports a pretty rich bird community there. Yep.
I got one here. It says, could climate chaos most likely higher temps be a factor in the bird counts that are coming up?
Christmas bird counts?
I guess that's what they're talking about. If you could repeat that.
Yeah. Would climate change, could that affect the results obtained through upcoming Christmas bird counts? And yeah, it certainly could. It depends upon whether, it gets colder or warmer. climate change is on higher unpredictability. We're not quite sure what we're going to get. But if you get a really cold day, yeah, you may not see as many things. May not mean long-term trends, but it could definitely sway the results. Hmm? Oh, it's crazy. So is that a comment or a question? Sure. Yeah. In fact, I had a student, an undergraduate, do an honors thesis of this to try and at least describe what was going on. So beginning about mid-October, somewhere around there, you start seeing crows coming together and start flying in groups towards the downtown area. And it really picks up. And so about this time of the year, there are thousands that are coming in. And they maintain those numbers until somewhere around late February, March, and then they start to go down again. They start leaving and the numbers, decrease. The decline, of course, at the end of the season, because they're going to spreading out, establish their territories and breed. Question is, why do they come to the downtown? What is going down? And I think probably there are two phenomena contributing to that. And one is that with large numbers, you find safety against predators. If you got, 500 birds in a park, the likelihood that a great horned owl is there is going to take you is pretty small as compared to if there are only 10. The other thing is it probably serves as an information source. Just as, for instance, turkey vultures, we know individuals will actually observe one another and they'll look for the crop and see whether it's full. And if an individual had a bad foraging day, they might follow that individual out the next day and find food. I think the crows probably are doing some of the same things. If you see a crow, you are a crow, and you see another one take off in a beeline in a direction, chances are it means that there was a good food source out that way. So I'm going to tag along and pick it up. But it's an amazing phenomenon. I wish we could get radio transmitters on them to actually follow them. There's so many interesting questions about that. But catching crows, tough. Yes. Mm-hmm.
But I feel like during nesting season, most birds are not happy to have their nest approach. I mean, did you see that part of your study? You see how you affected the reproductive rates just from handling the birds or approaching the nest all the time or being close to their nest? I'm sure they would stress them out. I don't know if they abandon nests or.
Okay, so the question is, to what extent do researcher activities affect the results of their reproduction? Do we, by our presence, actually reduce it? And so maybe I'm actually underestimating how successful they are because of our presence. Well, I've worked on, over the course of my career, in terms of reproductive biology, going to nests, probably at least a dozen different species. Only one of them that I ever find had a problem with humans entering it, and that was cedar waxwings. They are just the most fragile birds. They desert. If they're during egg laying or incubation, you go to the nest, they almost always desert. I have never found that to be the case in any other bird that I worked with. Abandonment is really quite uncommon. The idea that a lot of us were told by our parents, don't go to their nest, they're going to put the smell on the birds, you're smelling them and they're going to desert. No, that doesn't happen. That doesn't mean you still can't attract predators to the nest. That's definitely a possibility. And I can't honestly tell you to what extent our activities affected that. It could potentially influence it some. But the rates of success that we're finding here are pretty much in line with what we find for open cup nesting birds that nest on the ground. They're pretty similar. So I don't think it was a major problem, but I can't eliminate it either. Yes.